Hello, class. This will be a short introduction into Chapter 9 with the metric system. I'll have separate videos for the 9.1, 9.2, and 9.3. But since we are talking about the metric system, I thought it would be helpful to go through and do a quick review. This is something that in your science classes or if you're allied health, you'll definitely use the metric system regularly. So it doesn't hurt to go through um, and review what we're talking about. Uh, In as always in Blackboard, I've got the resources. In the lecture notes, a couple of things I have is the overview. That's just the topics. I'll get in that in the next video. Same with the formula sheet. So what I'm doing now is the metric system units review. I also have it filled out, but those are probably for the people who aren't watching the video, because that's what we're going to do in this video is fill that out. That's what I am using for this video is this document. All right, so let's go through the metric system. Let's do a quick refresher, and then we'll go on from there. Okay, so one of the things we're going to do throughout Chapter 9 is convert between units. We'll talk about dimensional analysis. That's it's really like unit conversion is what we're doing at this level. If you get into a science class, it can be a little bit more than that, but that's what we need to be able to do. We need to be able to convert like feet to inches, feet to miles, but we're also going to use the metric system. And so let's do a review of that. So let's start with length. And so one of the things about the English system is it has a lot of random, units that we use that aren't really connected. So for like length for the English system, we have inches, we have feet, we have miles. No, didn't leave these boxes big enough. What else do we have? We have yards. There's I was a sailor, so I remember talking about nautical miles, and so all of these are somewhat random. Um, and just the one thing about the metric system versus the English system or the American system now, I guess we should call it. I think we're one of three countries in the world that don't use the metric system. Which from a math teacher's perspective, the metric system is so much better. It's got a mathematical basis. It's all connected. The numbers are there for a reason. It's all based on powers of 10. Whereas the English system, it's a bunch of correction of random units that aren't really connected, particularly if we start talking about different types of measure. Um, but it's kind of hard to fight the inertia. Um, you know, I'm sure that as you went through school, they're telling you this is a metric system. You're going to have to learn how to use it. It's what we're moving to. Well, I heard that when I was a kid as well. So I don't know. Maybe our grandkids will do nothing but the metric. But when you have things like all our factories are we're made in the English system with English units. How much money does it take to retool those? That sort of thing. It's just it's I don't see us moving to it completely anytime soon. But particularly in the sciences and in medicine, metric gets used all the time. And so for any of your science classes, if you're in allied health, you definitely need to be familiar with the metric system. So this is this unit. Not only do we review the metric system, but we're also talking about skills to kind of help you convert those, which are useful in science classes. That's my little spiel for why we're doing the metric system. Okay, so that's for English. A lot of different ways to measure length. In the metric system, it's just meters. Now, one of the things, and we'll get into these prefixes after I go through all the units, but one thing, nice things about the metric system is you have your core measurement for a dimension for length, for volume, for mass, or weight, and the only thing that changes is the prefixes. So rather, in English system, if we're talking about something relatively small, we're doing inches, um, or we could go to, a little bit bigger as feet. If we want long distance, it's miles. If we're doing things like football stadiums, things like that, we're dealing with, or like carpet, we're dealing with yards. So like the unit changes every single time, the core unit. In the metric system, the core unit for length is always going to be meters, but we're going to change the prefix. And so that's one of the things you have to learn with the metric system is what the prefixes mean. Now, there's a lot more that I have here, but these are sort of like the main ones we'll talk about or see in the homework. Um, but if it's doesn't matter if we're talking about meters for length or for volume or for mass, like with grams, that's going to be the core unit in the metric system, and then just the prefixes change. Okay, so I think that to me makes a little bit more sense than just having random units that we use. For meters, it's always going to be a little m. Be careful with miles because sometimes we abbreviate that miles. If you're going to abbreviate miles, miles needs to be mi. So keep m for meters, mi for miles. How big is a meter? If you have a yardstick, it might be a yardstick, it might be a meter stick. Look at your yardstick. If your yardstick is 39 inches, a little bit longer, it's actually a meter stick. A meter is like 39.36 inches, if I remember correctly. So a meter is just a little bit longer than a yard. So that's sort of how I keep those straight. When we and again, kind of jumping down the prefixes a little bit, we talk about centimeters a fair amount. Well, a centimeter, a centi with an I means 1/100th of a meter. So a centimeter would be 1/100th of a meter, or like 1/100th of a yard, approximately. The way I remember it from when I first learned is that like the width of your pinky, that's approximately a centimeter. It takes 2.54 centimeters to make an inch. And then, so we're talking kind of small stuff, and we're talking centimeters. If you get into milli, um, that is 1/1000th of a meter. And so that is approximately like the thickness of a fingernail. So milli is pretty small. So anytime we're talking about inches, that the equivalent is usually centimeters. We don't really have an equivalent for millimeters in the English system because that's when we get into decimals of inches. The other thing is a kilometer. A kilo is 1,000 meters, and so a kilometer is, let's see, it takes 1.61 kilometers to make a mile. So a kilometer is like a little over half a mile. Right. So it always helps to kind of big picture have an idea of like what the units are we're talking about when we're doing. Okay, so that's for length. Now for volume, what do we have measurements for volume in the English system? Well, we have gallons, if you're buying gas. We have cups, pints, we have quarts. Run out of room. We have teaspoons, tablespoons. We have FL for fluid ounces, but fluid ounces are different than regular ounces. Um, what else? I think that's usually, if you have a background in farming, you may have probably heard of bushels. Those are the big baskets. I mean, again, there's all a random sort of collection. And unless you cook a lot, then like remembering how many pints are in a cup, how many cups are in a quart, how many quarts in a gallon, that can get all messy. So again, English system, especially with volume, is a lot of times we don't know our own system very well. What's the metric measure for volume? It's a liter. And it's either lowercase l or capital L. If you don't do, and I notice I did it in cursive, if you don't do a cursive lowercase l, then it looks like a capital I, so that can be a little confusing. So that's why I usually see it as a lowercase cursive L or capital L. A liter is roughly you got the 2 liter Coke bottles or pop bottles. If you take a large Kleenex box, that's approximately 2 liters. The closest thing to a liter in the English system is definitely a quart. I remember now, and I never can remember until I look at the conversion if a liter is slightly bigger than a quart or vice versa. I will get into that later. But a liter is approximately a quart. Now, the nice thing about the metric system is how these are connected. Like there is no connection between inches and gallons or cups and feet. Those are all just random stuff. But one of the nice things about The metric system, we'll get into this like later in chapter 9, but it's worth throwing out here as well, is that 1 ml, which is 1 milliliter, is one cubic centimeter. So there is a connection between volume and mass. So I don't know how many of you play dice games. This is not a normal size die, it's a little bit smaller, but it's roughly a centimeter on a side. And so when you make that a square, that's a cubic centimeter. Well, that's how big that's the volume of 1 milliliter. So if you think of, go back to like that half of a Kleenex box, I could put roughly 1,000 of these in half of a Kleenex box. So that milli is 1,000th. So it takes 1,000 of these to make a liter. But that's, when you hear cc, that's what we're talking about, something that size. All right. So how about mass? On the English system, most common one is pounds. We have ounces. Again, there's a fluid ounces is volume. Ounces by itself is mass or weight. If you get really big, we get into tons. Um, how many tons are in a pound? 2,000. So what is, there's not as, we don't have as many units of measure for mass. In the metric system, it's a gram, which is just lowercase g. Well, what is a gram? Well, here's another nice thing about the metric system. You take this cubic centimeter, this milliliter, you fill it full of water. That is how much a gram weighs. So a gram is, as you can imagine, relatively small. The closest equivalent to what we do in the English system is if you take 1,000 of these, you take that half of a Kleenex box, fill it full of water, then you get a kilogram. A kilogram is 2.2 pounds. So a pound is not quite half of a kilogram. That's the closest connection there. That's another nice thing about the metric system. It's all interconnected. Now, if you deal with medicine at all, you deal a lot with milligrams, or even really small doses would be micrograms. And so, like if you think of a milligram, if a gram is one of these filled full of water, a milligram would take this into 1,000 pieces, and then that would be a milligram. That's how much a milligram would weigh if you have the water. So milligrams are very small, but that's medicine dosage is where we see that. Right. Okay, so that is most of the three measures that we're going to do conversions with. Now, in temperature, we do have in the English system, it's Fahrenheit. Never can remember if it's IE or EI. It's a German. I think it's EI. That's why that's why we do capital F. And then for the metric system, it's Celsius. Sometimes it's called centigrade. That's the capital C. Now, when we get to converting temperatures, there are specific formulas that we use. You don't have to have those formulas memorized. You just have to know how to use them. But those aren't like the normal dimension analysis we're talking about. If you jump down to the bottom of the page, the boiling point of water in Fahrenheit is 212. The boiling point of water in Celsius is 100. Again, Celsius, the metric system likes its powers of 10. Freezing point of water is 32 degrees Fahrenheit. It is 0 degrees Celsius. I guess it could be 1, but then 0 makes it a little bit better 0 point, I guess. If you've ever heard of Kelvin, Kelvin is the Celsius temperature range, but lowered by 273 degrees. If you're wondering where that comes from, that has something to do with absolute zero. And so that would be a physics or maybe a chemistry, probably physics instructor question on why they're subtracting 273. But the Kelvin is just a sliding scale version of the Celsius. All right. So that's big picture. Those are sort of the metric system stuff. What you have to be able to do, not so much like remember, the normal units, those are pretty straightforward. It's knowing your prefixes. Okay. And so, and again, it doesn't matter if it's meters or if it's grams or if it's liters, works the same on all of these. If you notice, most but not all of the decimal prefixes end in I. So deci, centi, milli. Now, once you get into micro, like really small stuff, that doesn't end in I, but you notice we're dealing with powers of 10. So deci or deca, here's ends in I, here ends in A. Dec, DEC, that prefix means 10. So if you have a decimeter or a decigram or a deciliter, it's 1/10 of a gram, or if it's 1/10, that means there's 10, there's 10 decimeters in a meter. If you go to decameter, which is DA, that is, now we're getting larger. So there would be 10 meters in a decameter or 10 liters in a decaliter. So if we're up here, we're bigger than the original base unit. We're down here, we're in decimals. So like for centi and milli, or like these are the ones, like these are the three that we use the most. Kilo for 1,000, a kilometer is 1,000 meters, a kiloliter is 1,000 liters, kilogram is 1,000 grams. A centimeter or centigram or centiliter is 1/100th. So if you take that meter stick, that's a little bit bigger than a yardstick, you'll notice that it's numbered 1 through 90 because there's 100, and then they don't have 100 on the end, but there's 100 centimeters in a meter stick. And then milli, that's 1/1000th. And so, as you need to get used to your prefixes. I'm on the test. I'm going to expect you to know like your English to English conversions, unless they're like cups or pints. I expect you to know how to use your metric prefixes, particularly those three. You are allowed a formula sheet on this test, so if you think you're not going to remember those, then that's something on your page. But I will give you like the English to metric, but I'll share that in the other video. One of the things about the metric system, if you're just in the metric system, there is kind of a shortcut sometimes to the conversions. I'm not going to do this in class because I want us to be more consistent in how we do the conversions. I want to show you like the chemistry, like what we do for chemistry conversions. But basically, and this works, when you're doing conversion, if you're going from small units to big ones, like from inches to feet, you're going to have fewer feet, so you're going to divide. Well, since we're in the metric system that's all powers of 10, you're dividing by 10 or 100 or 1,000. So you're basically just moving the decimal. So if you're going from a small unit to a large unit, like centimeters to meters, the decimal ends up moving to the left. Now, if you're going from a large unit to a small unit, like meters to millimeters, there's going to be a lot more of the smaller unit. So you're going to multiply, or in this case, you're going to move the decimal to the right. I'm not going to talk a whole lot about moving decimals to the left and the right. Like with scientific notation, sometimes they talk about it that way, but sometimes common sense works better. So really, we're going to do our conversion with fractions, but I will throw that out there because I think like Allied Health, since they do nothing but metric system, they tend to do more of like moving the decimal depending if you're going to smaller unit, smaller or larger. But again, you kind of have to know what's the smaller, what's the larger unit. If not, then you can't really do that. All right, so here's a metric system. I do want to point out into the homework in 9.1. Let me go to that. So some of the questions in the 9.1 homework are not conversions. They're actually, do you have an idea for the metric system? Screen correctly. Yeah. So on this one, like here's a sample question. Alice is driving near Venice and sees a road sign that gives the distance to the city. Choose the most reasonable measure. 34 kilometers, 34 millimeters, 34 centimeters. So there are several questions in here. Basically, do you understand the relative size of the metric units? So, if you're driving, we're talking kilometers because we're talking miles. Millimeters, that would be 34 millimeters. That's like a little over an inch. 34 centimeters, that would be probably a little over a foot. Millimeters are very small. Centimeters are equivalent to inches. The next kind of equivalent. If you're talking miles, you're going to talk kilometers. That's what some of your questions are going to be. And the homework is just, are you going to understand that? The basic metric stuff. And then there's a lot of conversions. That'll be a different video. Okay. So that is it for the metric system. So if you haven't used it in a while, that's hopefully a helpful review. And again, if you're taking any science class or if you're in allied health, you definitely need to be used to dealing with the metric system. All right, that is all I have for this video. Next videos will be getting into the actual conversions from. Have a good day.